As you have done in activity 11.2, one method of finding the density of a liquid is to measure the volume and the mass of it and then calculate its density. But since it is a time-consuming and difficult process, there is an equipment that is specialized to measure the density of a liquid, and that is known as the hydrometer. Now this is a hydrometer. As you can see, the hydrometer is made up of a thin glass tube in which the lower part is blown to form a bulb, and this bulb is filled with lead shots at the bottom. This is done in order to make sure that part of the tube is submerged and float vertically in the liquid. And here you can see a hydrometer which is immersed in a liquid. And you can see that the hydrometer floats. This thin tube of this hydrometer is a graduated stem, which means a scale is marked in this area. When the hydrometer is partially immersed and floating in a liquid, the length of the immersed part depends on the density of the liquid. Suppose if the density of the liquid is high, then the hydrometer would sink less, and therefore the part of the hydrometer that is immersed in the water would be less. If the density of the liquids are low, then the hydrometer would sink more, and part of the hydrometer which is immersed in the liquid would be more. So the upper tubular part of the hydrometer is graduated, like I said. So it's graduated in such a way that the density can be read at this point by the depth of its immersion. The scale in this upper tubular part of the hydrometer is marked in such a way that the density can be directly read by the depth in which it is immersed. Here's a picture of a hydrometer that is immersed in an alcohol. And as you can see, this area is marked with a scale. And from this scale, you can measure the density of the liquid. Now look at figure 11.4. There are three different types of liquids: liquid A, water, and liquid C. The hydrometers are immersed in each of these liquids, and you can see that the hydrometers are floating. If you look at B, you can see how the hydrometer floats in water. And if you look at liquid A, the immersed height of the hydrometer is less compared to that of water. And if you see liquid C, the immersed height or the immersed length of the hydrometer is more in liquid C than that of water. So what can you conclude from this? You can understand that the density of liquid A is higher than water, while the density of liquid C is less than water.
Hold the hydrometer by the top and slowly lower it into the test cylinder. Just before you let go, twist it so that it slowly spins. This ensures that no bubbles cling to the hydrometer and cause it to float higher than it normally would. Drop the hydrometer while twisting it. If bubbles do happen to be a problem in your test sample, just pour the sample back and forth between the test cylinder and another sanitized container until the bubbles dissipate. Also, make sure the test cylinder is level so the hydrometer does not touch the sides. Finally, note the level at which the hydrometer emerges from the liquid, which is right here. The surface of the liquid will be concave. This is called the meniscus. Take the reading from eye level at the bottom of the meniscus.
I hope that gave you a clear idea about the use of hydrometers to measure the density. There are many kinds of hydrometers to measure different kinds of liquids. Therefore, it's very important that when we are doing a measurement, we pick the right kind of hydrometer. And there are also different kinds of uses of hydrometers. Now, as you know, cow's milk contains approximately 90% of water. Other than water, there are other components like lipids and proteins. So, because of the contribution to density from these other components, the density of milk is slightly higher than that of water. We already saw that in the table. The density of water was 1000 kilograms per cubic meter, whereas the density of milk was 1030 kilograms per cubic meter. So, the amount of water added to milk can be decided by measuring its density. So there's a special kind of hydrometer that is used to measure the density of milk, and that is known as lactometer. Then there's a special kind of hydrometer used to measure alcohols like wine and beer, and it is known as alcohol meter. As you know, lead acid batteries or car batteries use acid, and according to the changes in the battery, the density of the acid changes. Therefore, the condition of the batteries can be examined by measuring the density of acid with a hydrometer. And then we have a hydrometer that can be used to measure the density of soil. We need to obtain a constant mass of soil and then dissolve it in a constant volume and then calculate its density by using a hydrometer. This method can be used to determine the composition of a soil sample. Seawater has a high amount of salts dissolved in it. So there's a special kind of hydrometer called seawater hydrometer, which is used to measure the density of seawater. Since there's a lot of salts in seawater, the density of seawater is higher than the normal fresh water. And then there's a kind of a hydrometer known as metrolac, which can be used to measure the composition of rubber, or we can measure the density of rubber and determine its composition. Now, this brings us to the end of this lesson, and here's the summary of the lesson. Density of a substance is the mass per unit volume of that substance, and here is the equation for density. Density equals to mass divided by volume. The standard unit of density is kilogram per cubic meters. So density is a vital physical property of a substance, and it differs from substance to substance. Hydrometer is used to measure the density of liquid, and density is a criteria which determines the quality of lipids and solutions. So children, I hope you understood density very well. So please attempt the end of chapter exercises in the textbook, and Assalamu alaikum to all of you.